Hello everyone, this is Jia. Today I will start the final presentation on the project CDSS for Hospital Discharge Decision Making on behalf of our Team 22, Health Informatics. Our team consists of 6 members. Everyone contributes as a developer as well as having another role. I work as the project manager. Lan Yin Zhang is our full-stack developer. Qingguo Chen works on the quality assurance. Sihao Wang and Yilong Hu work jointly on the documentation part. Wei Wu is in charge of application build and deployment. Here, we would like to thank our external mentors for providing us many useful information on this project. Also, we would like to especially thank our TA, Dan Abel, for his great support during this semester on this project. We leveraged the research on the project background done by previous teams. We realized that the problem lies in the high rate of unplanned hospital readmissions, which shows low-quality healthcare. This kind of unplanned readmissions not only make the patient suffer, but also will increase the unnecessary medical cost. So a smart solution was brought up by our mentor, Dr. Cox. That is a clinical decision support system to help clinicians to decide when to discharge a patient. The alpha version of the CDSS application for hospital discharge decision-making uses patients' data on Cerner Fire server to feed new data to mathematical model and then to generate a discharge recommendation. After meeting with the external mentor, we were told that the users are not very satisfied with the display and interface in the application they are using now. Therefore, our goal is to develop and improve the graphical user interface based on previous work on this CDSS as a Smart on Fire application. In the existing version, the information is just displayed in order. The only basic panels of information that plainly display 55 fields needed for decision, as shown on the right screenshot. As requested, the users want to see that all information in one page, and the most important, the suggested decision for discharge should be highlighted. Also, they want the observation information in the center. So our main goal is to improve the UI to support up to 7 panels available in an intuitive and interactive way. To reach the goal, we studied the Smart on Fire network model. The technology stack used here in this project include, but not limited to, HTML, JavaScript, Bootstrap, and Plotly.
Our web application can be easily built and deployed locally using Docker and Gradle. In this slide, I'm showing you how to run our app locally. Firstly, a wall artifact of our web application can be built using Gradle and then deployed in a Docker container which has a Tomcat installed. Our database is held remotely on the GSU server, and our local web application is linked to this remote database. The build and deployment process is automated by using Gradle task and Docker Compose. We also have our application continuous built and deployed on the HDAP server. Briefly, the Jenkins server could detect any new commit in our GitHub repo and perform or automate build for our project and the Docker image, and then push the build Docker image to the HDAP Docker registry and notify the Rancher server to deploy the pushed Docker image on the Docker Swarm. You can view our application using this URL.
We successfully deployed our application on HDAP server. So I'm gonna just use this server application to do the following demo. First, we start from Cerner website. There, we have 3 apps for different tests. One for server test, one for local test, another for Docker test. So I just click the server test. We began testing by selecting the patient Martin Green. Then it's gonna send her patient information into our application. The application gonna run the model to do the predictions. So we developed the user interface to show the results. Here you can see in the left we have basic patient information. In the middle we have the decision and have a discharge rate and a readmission rate time series plot. In the right we have other file resources list. For observations and conditions, we make a table to show all the results. The table is sortable. We have value in different colors. The red is the higher value than the normal range, so all the column can be clickable and sortable. Basically, our application is a clean dashboard with interactive plots to show the prediction results and sortable tables to present file resources. During development of the application, we met the following challenges. The first 2 challenges made us spend a lot of time to debug the previous team's codes. The last 2 challenges made us a bit difficult to fully test our application.
This is the final Gantt chart of our team project. We successfully completed the tasks planned at the beginning of the semester timely. You can visit the full detailed Excel file of Gantt chart by clicking the link below the table.
We successfully implemented the user interface for CDSS application, but because of the limit of time, some backend features have not been implemented yet. We would suggest the next team to implement the following features. The patient ID information could be stored in the local database. The doctor can search and select patient ID to do the queries. And there is a periodic backend task to make predictions for other patients stored in the database. The prediction result is automatically stored in the local database. Then send the backend data to front end when doctor to view those predictions. So this is our final presentation. Thank you for your attention.